Every space movie you've ever seen is lying to you a little. Roaring explosions, engines screaming through the dark, ships colliding with a deafening crash. It's great cinema, but it's not physics. If you were floating a few kilometers from an actual explosion in space, you wouldn't hear anything. No boom, no echo, nothing. Complete silence. That's a hard idea to accept, because on Earth we're surrounded by sound all the time: traffic, thunder, someone whispering across the room. Our brains just assume that if something moves, it makes noise. Space doesn't play by that rule. So here's the puzzle: if space is truly silent, why does NASA keep releasing audio clips people call the sounds of space? Are those real, or is it all a bit of a trick? That's what we're digging into: why silence is the default state of the universe, how scientists still manage to hear events happening billions of kilometers away, and why the very first sound in the universe might have existed before a single star had formed. The real answer turns out to be stranger than anything Hollywood came up with. You've probably heard the tagline from Alien: "In space, no one can hear you scream." It's one of the rare sci-fi lines that actually holds up scientifically. It's not about distance, either. Even someone standing right next to you in a vacuum wouldn't hear a word you said. The reason comes down to how sound works. When you speak, your voice vibrates the air around you, and those vibrations pass from molecule to molecule until they reach someone's ears, like a row of dominoes falling one after another. Take away the molecules, and there's nothing left to carry the vibration. The chain just stops. That's basically what space is: a near-total vacuum, with so few particles floating around that sound has nothing to push against. It's like trying to make ocean waves without any water. The mechanism simply isn't there. This is why astronauts working outside the ISS can't hear each other directly, even standing just a few feet apart. Their voices go out as radio signals through their helmets instead. Take away the radio, and it's dead silence. But the universe wasn't always quiet. Here's the twist: today's universe is silent, but it didn't start that way. Go back almost 13.8 billion years, to just after the Big Bang. There were no stars, no planets, no galaxies, just a blisteringly hot, dense soup of glowing plasma filling everything. And unlike the empty vacuum we have now, that early universe was packed with particles. Wherever there are particles close together, sound can travel. Scientists think massive pressure waves rippled through that infant universe, creating what were essentially the first sounds in cosmic history. Not sounds a human ear could pick up. The frequencies were absurdly low, way below our hearing range, but by studying the faint patterns baked into the cosmic microwave background, researchers have managed to reconstruct those ancient vibrations and shift them up into a range we can actually hear. In a strange way, the oldest sound we've ever recreated is an echo from the birth of the universe itself. And that's really just the setup. Because even though open space is silent, planets, storms, magnetic fields, and even black holes have all found other ways to produce something that sounds a lot like sound. So what is NASA actually recording? If space is silent, why do NASA's audio clips exist at all? Did sound somehow figure out how to cross the vacuum? Not quite. What NASA releases isn't sound in the traditional sense. Space is buzzing with activity. Our eyes can't see: charged particles moving through magnetic fields, stars throwing off streams of plasma, planets generating their own electromagnetic waves. None of that is sound. It's electrical and magnetic activity. Spacecraft instruments pick up these signals, and scientists convert the frequencies into something audible. It's called data sonification. So when you hear that eerie voice of Jupiter, or the unsettling whistle attributed to a black hole, you're not hearing space itself, you're hearing scientific data translated into sound. It's a real measurement, just given a form our ears can process. Some of it sounds like ghostly whispers, some like deep musical tones, and a few clips are unsettlingly close to something that sounds alive. None of it is fabricated, it's just translated. If you could actually hear space. Let's play with a hypothetical. What if sound really could travel through the vacuum? The first thing you'd probably notice is the sun. It looks peaceful from here, but the sun's surface is in constant chaos, plasma bubbles rising and collapsing every second, magnetic storms releasing enormous bursts of energy, shock waves tearing across its surface. If that noise could reach us, scientists estimate it would be an unbroken roar, day and night, for your entire life. Thankfully, the vacuum between us and the sun is the best soundproofing imaginable. Other planets have their own signatures. Jupiter has the strongest magnetic field of any planet in the solar system, and the charged particles trapped inside it generate powerful radio emissions. Sonified, it doesn't sound like wind or thunder, it almost sounds like singing, full of rising whistles and strange electronic chirps. Saturn's rings look calm, but they're constantly interacting with the planet's magnetic field, particles colliding, currents flowing, invisible waves rippling outward. Converted to audio, it comes out sounding like a mix of soft wind and distant music. Beautiful, and a little unsettling. Mars tells a different story altogether. Its atmosphere is so thin that when NASA's Perseverance rover turned on its microphones, scientists heard something no one had experienced before: Martian wind, with higher-pitched sounds fading almost instantly. A voice on Mars would sound quieter, deeper, and oddly distant, even a few steps away. Every world, it turns out, has its own acoustic personality. None of that compares to what might be the most mysterious sound in the universe, the one tied to a black hole. A black hole itself doesn't make sound, it's surrounded by vacuum like everything else. But the material around it is anything but quiet. Hot gas, magnetic fields, and huge clouds of plasma spiral around at incredible speeds, colliding and compressing in ways that generate real pressure waves in the surrounding gas. The most famous case comes from the Perseus galaxy cluster, roughly 250 million light-years away. Using NASA's Chandra X-ray Observatory, astronomers detected ripples moving through the hot gas around the cluster's central black hole, ripples that behave just like sound waves, at a frequency about 57 octaves below middle C. Far below anything a human ear could register. To make it audible, scientists sped the signal up by millions of times, producing a deep, haunting tone that went viral as the sound of a black hole. Technically, it wasn't the black hole speaking, it was the surrounding gas carrying enormous pressure waves. Still, it's one of the more remarkable pieces of astronomical data ever turned into something we can listen to. All of this points to something bigger: the universe never stopped communicating, we just haven't always had the tools to understand it. Our eyes catch a sliver of the electromagnetic spectrum. Our ears catch a narrow slice of frequencies. Everything outside those windows is effectively invisible and silent to us unless science finds a way to translate it. That's exactly what modern spacecraft are built to do. They're not just cameras, they're measuring magnetic fields, plasma waves, radio emissions, charged particles, X-rays, signals we could never sense directly, and turning them into sound, color, and image. In a real sense, technology has become an extra set of senses for us, and it keeps getting sharper. Future missions may pick up entirely new kinds of signals, from neutron stars, galactic collisions, or things we haven't even thought to look for yet. So, what does space actually sound like? If you were floating out there without a radio, the honest answer is almost nothing. No explosions, no roaring engines, no echoes, just silence stretching in every direction. But underneath that silence is an entire hidden layer of energy, radiation, and vibration, and with the right instruments, we can finally start to make sense of it. Hollywood gives us the noise. The real universe gives us something quieter, stranger, and honestly more interesting. Next time you look up at the night sky, remember it was never really silent. We just hadn't learned how to listen yet.